Hi everyone. Today we are going to talk about basic probabilities. Probability is a branch of mathematics that describes the chances that an event will occur. So the way we find the probability, P, of an event, E, is by taking the number of times it occurs by putting it over the total number of possible outcomes. So probabilities can be represented in a variety of different ways. It can be represented by fractions, decimals, or percents. Most of the time, when a question is asking for the probability of an event occurring, it is asking for the fraction or the decimal. Okay, let's do a few examples which you should already know. So example number 1. A fair die is rolled. What is the probability of landing on a 6? Well, the total number of possible outcomes is 1 through 6. So that would go on the bottom. There are 6 possible outcomes. What is the probability of landing on a 6? Well, how many 6s are there? 1. So 1 out of 6. What about example 2? What's the probability of landing on an even number? Well, the even numbers on a die would be 2, 4, and 6. So that's 3 out of a possible 6. Therefore, that reduces to 1/2. How about example 3? What is the probability of landing on a number less than 7? Well, let's look at all the numbers less than 7 that are on a die. So 1, 2, 3, 4, 5, and 6. So all of those numbers appear on a die, so technically 6 out of 6, which reduces to 1. Number 4. What is the probability of landing on a number greater than 7? Well, the only numbers on a die are 1 through 6, so are there any numbers on a die that are greater than 7? And you should say none. So therefore, the probability is 0 out of 6, or simply 0. So my question for you now is, what do examples 3 and 4 tell us about the range of all probabilities? So the range of all probabilities really goes from 0% chance of it happening to 100% chance of it happening. So it's either never going to happen, 0, or it's always going to happen, which is 100. So this we'll say is never happening or always happening. And with example 3, we didn't use percentages. We just said 0 never happens, 1 always happens. So all probabilities should be fractions between 0 and 1, or decimals between 0 and 1. Okay, let's talk about the next topic. The next topic is a complement of an event. It's denoted by, or symbolized by, A with a little prime on top. That's what that dash is called. So the probability that an event will not occur is represented by this right here. The probability of A complement is equal to 1 minus the probability it actually happens. So this will make more sense if we do an example. So example number 1. The chance of rain on any given day in Florida is 75%. What is the probability that it will not rain? You know automatically that the answer is 25%, but how would you do this? You would take the 100% chance, subtract it from 75, and get 25%. Okay, how about example 2? The probability that an event will occur is 0.57. What is the probability that it will not occur? Well, like we said before, up here, all probabilities are between 0 and 1. So the 100% in this case would be 1. So we would do 1 minus 0.57, and we get 0.43. So the probability that it will not occur is 0.43. Now, how about if I give it to you in terms of a fraction? So the probability that an event A occurs, that's what P of A stands for, right here, P of A is 1/4. That means the probability of event A happening is 1/4. Find the probability of its complement. That's what this is asking. So you would do, again, 1 minus 1/4. But isn't 1 the same thing as saying 4 over 4? So 4 over 4 minus 1/4 is 3 over 4. So these are three examples, one with a percent, one with a decimal, and one with a fraction. All right, let's move on to the next page. Okay, let's discuss OR probabilities. And the easiest way to do this is through an example. So example number 1 says, what is the probability you roll a 1 or an odd number? Well, let's list out what I have. I have a 1 and I have odd numbers, 1, 3, and 5. Now, there is repeat, and the repeat is within the ones. So that's where when I say add the probabilities and subtract the overlap. So if you wanted to be technical with the formula, we could just say that the probability you roll a 1 is 1 out of 6. Add the probability that you get an odd number, which is 3 out of 6, and then subtract the overlap. Here's my overlap. There's 1 out of 6, which is repeated. So these will cancel, and you'll be left with 3 out of 6, which reduces to 1/2. Or you could just look at the problem like we're going to do for number 2. So for number 2, what's the probability we roll a 5 or an even number? So either a 5 or 2, 4, 6. There's no overlap, so we could just look at it and say 4 out of 6, which reduces to 2/3. Okay, now I'd like to discuss independent events versus dependent events. 2 or more events are said to be independent if the outcome of the first does not affect the second or future events. 2 or more events are said to be dependent if the outcome of the first does affect the second or future events. So here's the formula that we're going to use. If I want to find the probability of 2 things, event A and B, all I'd have to do is multiply their probabilities together. So we have an example where we have a drawer that contains 3 red paper clips, 4 green, and 5 blue. Just for fun, we're going to need a total, so we're going to have 12 total paper clips. So question number 1 says, what is the probability that the first paper clip is red and that the second is blue, given that I replace it after I pick it up? So first off, before we even answer anything, are these events independent or dependent? I say that they are independent because I am replacing one of the paper clips and putting it back. So if I put it back, the odds are still the same. So what we're going to do is find the probability of the red and multiply it by the probability of the blue. And what's the chances that we get a red? Well, there are 3 red paper clips, so we could say 3 out of 12 times. Now the probability of the blue paper clips, there are 5. So I do 5 out of still 12 because I replaced it. So if you multiply these together, tops with tops, bottoms with bottoms, you'll get 15 over 144. You don't have to reduce it, but you can. All right, let's look at the second example. What is the probability that the first paperclip is red and the second is blue, given that I did not replace it? So let's see. We're going to find the probability of red times the probability of blue. So first, are these events independent or dependent? And the answer is dependent because the second is dependent on what happened in the first because I'm not replacing it. So the probability of red is still the same, 3 out of 12. Now the probability of blue is still 5, but now out of 11. It's out of 11 because I didn't replace the one that I took from the first spot. So my answer is 15 out of 121. And again, you don't have to simplify it unless you want to. The next page we will do in class tomorrow. See you then. Okay, lastly we're going to talk about probabilities involving combinations. So let's look through an example. Example number 1. A gumball machine has 5 yellow, 3 green, 4 blue, and 1 red gumball. If 5 gunballs are chosen at random, what is the probability that the machine dispenses 1 yellow, 2 green, and 2 blue? So in order to do probability, we need what we want over what we have. So we need to figure out all the possible ways that I can get this. So that's where, since there are 5 yellow, we have 5 yellow, and we want to figure out how many groups of 1 we can make. So 5C1, order doesn't matter how we pick them, but these are the number of ways that we can. And we want to multiply that by, since I want 2 green, I have 3 total. So 3C1 times blue, 4 blue. So 4C2. So this expression on top is all of your possibilities. And I need to divide it by how many ways I can choose those 5 gumballs. So there's a total of 13 gumballs, and I want to choose groups of 5.